In this video, I'm going to do something a little different. Recently, I was looking at the Look Mom No Computer channel because I like that channel. Great, interesting stuff. Funny guy, and great projects too. And I noticed he was looking through old electronics magazines from Europe, I guess specifically England, and going through them and looking at the projects, and in some cases duplicating the projects to see how they worked. And when I looked at that, I said, hey, you know, I've been doing electronics magazine writing for a long, long time. As a matter of fact, the first article that I ever had published was in October of 1976, when I created something called the Panamix, which was a low-cost panning mixer project. And it started a love affair with electronics magazines and electronics projects. And I thought, I have a ton of these magazines, copies of which I had my articles appear in, and I thought I'd like to share some of them with you. So that's what I'm going to do in this video, and if you like it, I'm going to continue on with other projects from other ones of the magazines in which I had my articles published. So let's take a look at those magazines starting right now. So this is, like I said, the first electronic magazine that I had my article published, and it was called Low Cost Panning Mixer. And let's see. Here it is, Bill Panamix. It's on page 50. So let's take a look. Here it is, Bill Panamix. And it's a simple device. Just has two op amps for the stereo, runs off two batteries, and panning mixers, with panning, and one is the panning and one is the input level. And I used this in my home recording studio for the longest time. I used batteries because I wanted the least amount of hum or anything like that. I wanted it to be as pure as could be. And again, that was October 1976. Showed you how to make the case. Here's the actual printed circuit board layout. And that was pretty neat. And then in June of 1978, I created a Fuzz box, and this was based on a germanium transistor and an op amp running at lower than normal power supply voltages, and it gave a really nice feel. And actually I made another video about this, and here it is. You can see the device, and you notice I'm only running on plus 1.5 and minus 3 volts, and here's the input signal and various stages of distortion that are created by this with this teeny little printed circuit board. Here's one from 1978, elementary electronics, and I created something I call the Disco King. There weren't many, you know, right nowadays there's all kinds of drum machines, you know, and from the recent past, the classic 808s and things like that, but there was nothing like that back then. So I actually created Disco King 43, page 43. Here it is. Don't you like that crazy disco era artwork? And it really created a nice drum system, created around some different ICs. Here we have op amps, transconductance op amps, and some diodes and some passive components. And it worked out really nice. I used it for many years. And then way before you could get things like this, I created something called the Octavisor, which was a device, page 33. I created something called the Octavisor that allowed you to put in a guitar signal, and it would create a signal 1 octave below, and then you could mix it together, which is quite easy nowadays, but then it wasn't. Connect any electrified or electronic musical instruments to the Octavisor, and your instrument's signal frequency output is expanded threefold. In addition to the single frequency output signal, square waves at 50% of the frequency, which is down 1 octave, and one at 25% of the frequency are available at the Octavisor's output. All 3 signals can be mixed in any proportion desired using the blend and prime controls. The composite output signal can be used immediately or further processed using filters or other such devices. I used this. This was pretty cool. Then in September of 1979, I created something called the Person, which was a whole family of percussion synthesizers. As you can see, I had little drum pads and then oscillators based on, of course, the classic twin T oscillator. I had a snare cymbal, a snare attachment, which was, of course, a noise source. Had a modulator, a pulse generator, and a series of other devices, including a sequencer. So in 1979, that was a good thing to have, especially since anything you'd want to buy at that time was extremely expensive, and this was really cheap. And then, based on this, in December of 1979, I created an audio effects sound machine. And this was called the Audio Artist. And on page 60 here, let's see what that looks like. And I remember back in the day using this to create all kinds of sound effects. And it was really cool because I could control the dials and come up with things that almost sounded like a human voice, bubbling, all kinds of stuff. And unfortunately, this is the actual prototype that I sent to the magazine. And I used transfer lettering to transfer all of these words onto the front panel, and coated it with some lacquer so that it wouldn't come off. Sent it to them. I don't think I ever got it back, and I really missed this one. So at this point, I'm going to stop with all of the magazines, even though I have things from Computer Electronics, Hot Cocoa magazine, which was a magazine that was alive for a few years on the color computer, Electronics Now, Popular Electronics again, Electronics Now, and so on, Radio Electronics. I'm going to stop here, and I'm going to recreate this one. Because let's take a look. It says, whether you're an amateur recording engineer, electronic musician, or simply a sound bug, or chronic knob twiddler, the Audio Artist is sure to appeal to you. It's a special effects generator which can be used to create such sounds as the wail of a siren, the bubbling splash of a rock falling into a pond, the stock Hollywood sound of a flying saucer, the complex whirring generated by some futuristic machine, and much more. The Audio Artist's 5 controls interact with each other, resulting in a large variety of possible sound effects. The project can also double as a metronome, whose rate is variable from less than 1 Hertz to more than 250 Hertz. Displaying the output of the Audio Artist on oscilloscopes all creates some interesting effects. The project is easily built, and the total cost of construction is less than $25. And actually, I'm going to tell you right now, I did recreate this, and I guess things were a little more expensive then, at least electronics, and I didn't spend a whole lot of money doing this. The funny thing is, this uses a series of 1458 or 5558 ICs, and I actually had in my electronic box 5558 and 1458 from the 1970s, and I'll show you the date codes when I build this up. I did have to buy the MPF 102 device because I didn't have any more of those, but most of all the other stuff I had in my junk box. Now I'm going to want to read this whole thing to you, but effectively this device creates oscillations triggered by this circuit over here and varied by the resistance of this FET, field effect transistor, controlled by this device over here, and then is buffered here. And battery power is used, 2 9-volt batteries. Both of these serve as oscillators, low frequency oscillators, low to mid frequency audio, and this one creates a square wave, and the square wave goes into this shaping circuit, which creates a positive trigger pulse that continually triggers the twin T oscillator. And this is really just a twin T oscillator. You might notice I have 2 capacitors here only because I didn't want to use a different value. This is supposed to be 0.2 microfarads. So since I was using 0.1 microfarads all over the place, I just took 2 of them, put them in parallel so they add up to 0.2. I have a control here which controls the level of the trigger pulse. This controls the frequency of the trigger pulse. This is a triangle wave creation device, and the frequency of that is controlled by this potentiometer, and the level is controlled here, which goes through a 470 ohm resistor into the gate of this FET and changes the effects here. I also have a sustain pot over here which also changes it. It's almost like sweeping a filter. It's really interesting. And then this is just a buffer that inverts and sends the signal out to a jack. So what I'm going to do is I had a printed circuit board, and I want to show you the printed circuit board. Let me bring this up so you can see it. That's the printed circuit board. And of course there's the parts placement. And I use this and the schematic diagram to create or to recreate this audio artist. Here's what I originally had here, as you can see, and this metal piece was with a screw in the middle. I would put the 2 batteries in, and here's the circuit board, and here's all the controls, and here are the 2 battery clips. So I'm not going to make a printed circuit board. I'm just going to do this on a solderless breadboard, and I'm going to show you the signals it creates on an oscilloscope, and I'm going to let you listen to all of the different effects. Now, here's the schematic that was in the article. I scanned it in and reprinted it out, made sure that I checked everything out. I did notice that there were 1 or 2 errors, like for instance, both of these pots are labeled rate, and actually this one should be labeled level. And you can see this yellow marking here, and what that is, as I created it, as I created the circuit on the solderless breadboard, I traced everything and made sure that everything was working right. Of course, it didn't work the first time. I forgot to do a few things and the like, but I did wind up creating the device. And here is the device. And I'm gonna bring this down so that you could see it a little better. There we go. So this is the Audio Artist, and I did my sophisticated markings here with a pencil on a little piece of fiberboard. And here's the circuit itself. And I have 3 test points here that I've pulled out. This test point is for U1, which is the square wave generator that is shaped to create the pulse to trigger the twin T oscillator. This one down here is the triangle generator that modifies the source to drain resistance of the FET, and this is the actual output. So we're going to use these to feed into the oscilloscope and see what's going on. And of course, here's the 2 batteries. Let me turn this over so you can see the wiring. Here are all the different pots and the labels that I have. You need 2 A-taper 500K pots or a log taper. You need 2 100K linear taper pots, and you need 1 linear taper 500K pot. I put a switch in to control the power, and here's the output jack. So I'm going to put the actual layout of this on the screen so that you can see it a little better, and then we'll go in and start looking at the various signals that come out of here as we adjust. But first, remember I said I wanted to show you the date codes on these devices. Here's U1 and U2, both 4558s, and notice the date codes, the 50th week of 1977 and the 48th week of 1977. And both of these devices are working just fine. 45 years old and they're still working fine. Up here in the corner you see the MPF 102 and the way the leads have to be bent in order to get it correctly into the solderless breadboard. Now if we move down the end of the breadboard, here's U3, a 1458, and that's the oldest one because that's only the 41st week of 1977. Again, like U1 and U2, U3 is working fine. Amazing, these devices seem to last forever. So here's the setup. Let me turn the unit on. Now, channel 1, which is on the top, is connected to U1, which provides the square wave, and channel 2 over here is connected to U3, which provides the triangle wave. So let's look at the tempo here, which is U1, and as you can see, as I adjust this, it changes that frequency of that square wave, and if I go really far it starts distorting that square wave, but it's still there. Channel 2 has the triangle wave, and as you can see, that the higher up it goes, the better looking the wave is. As I decrease the frequency, it tends to flatten out on the top, but it's still a fairly good square wave. So those are the 2 waves that effectively trigger the twin T oscillator and modulate the sound by changing the MPF 102 response. Now I'm going to take channel 1 and I'm going to move that to the output. There we go. Well, my oh my, that is pretty big. Let me lower that a bit. There we go. And I'm changing the tempo. I'm getting more of those. Now, if I change the sustain, you notice that changes how much the twin T rings, and if I change the frequency and the depth, you notice it tends to have a very strong effect. As you can see, the output signal varies significantly with these controls. And as you see, if I move the tempo all the way down, you see it only triggers every once in a while. Bring it up, it's triggering there. But if I turn the level down all the way, I don't get any oscillation because there's no triggering of the twin T. And the more I put the level up, the more triggering I get. It tends to ring more. So what I'm going to do now is I'm going to connect the output to a audio source so that you can hear what I'm doing. I've gone through this and I've created the different sounds that I talked about in the beginning of the article, and I'm going to create those for you and you can listen to them. So let's get started. This sort of sounds like that bubbling sound. Now let's try a siren. Now let's try a metronome. How about a flying saucer? Now let's try a complex whirring of a futuristic machine. Let's see what we can do with that. And now I want to try to recreate a human voice saying, yeah. Well, those are some examples of what you can do with the audio artist. I find myself just fooling around with this for hours on end. Remember, the design is from the 1970s. Now, if you stayed with me throughout this whole thing, I would really appreciate if you'd push that like button and share it with your friends or anyone else. And tell me what type of project you'd like to see next. Maybe electronic music, biofeedback, interfacing with computers. I'd really like to hear from you. Until this next time, I'll talk to you again.